All right, Prob-Stats students. Today we're going to look at frequency distributions and histograms. Histograms are similar to bar graphs, but they are different. Bar graphs tend to be with qualitative, categorical data. Histograms are with quantitative numbers. So we can't use them interchangeably. So histogram may look like a bar graph, but there are a lot of differences. And histograms get used a lot more than bar graphs in more advanced level statistics. So just keep that in mind. Histogram, differences from a bar chart or bar graph. The bars have equal width and always touch. So you have to make sure they touch. If you draw a histogram and the bars are separated, immediately wrong. Width of the bars represent quantity. Height of the bars represent frequency or relative frequency. We will talk about both of those. Okay? There's an example of a histogram. It does need some more things on it. Notice frequencies here. Measured quantity, what you're talking about, and then it does need a title. Can't forget our title. All right? So to construct a histogram from raw data, decide on the number of classes. So 5 to 10. Typical. If you have a bigger, much larger data set, you could definitely have more than 10. For what I'm going to ask you to ever construct in class, that's going to be 5 to 10. Okay? You want to, and a lot of times you get to pick. So find a convenient class width. Okay? We need to organize the data into a frequency table. So we got to make the table before we make a histogram. Sketch the histogram, make a key, indicate the values in the intervals. And don't forget our title. When I say key, I'm meaning a key and a title, and that includes everything. So finding class width. This is what students struggle with the most. So what you're going to do, you need to find your largest and smallest data values. Biggest and smallest number. And you're going to subtract them. Then you're going to divide by the number of classes that you choose. A lot of times I will pick the number of classes based on what my largest and smallest data value are. And then I try to divide them to see if I can make it a convenient number. Because I'd rather have my class width a nice whole number. Having it as an ugly decimal, it just makes more work. It's not impossible. It's just more work for us to do. All right? And then if we do get a decimal, we are going to increase to the next wholest number. So if you get, let's just say, 7.2 is your class width, you're going to make that 8. I know that's against traditional rounding, and that's why sometimes students struggle. They round 7.2 down. Everything has to be rounded up. But if you can make it a nice, convenient number, then you don't have to worry about rounding. So that alleviates that issue. So here's an example. We have this list of data. Okay, got a bunch of numbers. Notice they're decimals, no big deal. So we're going to use 5 classes. Why 5 classes? Well, just because. Because 5 was a nice, convenient number, so that's what we picked. So we're going to take our largest number. So we have to find it. We have to locate it. So here's my largest number. Here we go. 24.7. There it is. I don't know if I can use the pen or not. Nope, that's not the pen. So I was hoping it would write on there, but there it is. Maybe that'll work. Here we go. So, yep, highlight. So there's my largest number. And then my smallest number is right beside it with the 0. Okay? Okay, I guess I got to hit the pen each time, but okay. You see the biggest and smallest number as I'm having technical difficulties. That's okay. So 24.7 minus 0 divided by 5 is 4.94. The one thing I would make sure in your calculator, I know it doesn't matter because it's 0, or it could matter. You got to subtract before you divide. Make sure you do that. So it's 4.94. We're not going to work with class width of 4.94. We're going to round that up to 5. So frequency table. You determine the class width. Boom. Already did that. Create the classes. May use the smallest data value as the lower limit of the first class and add the width to get the lower limit of the next class. Tally the data into classes. Those are the directions. Might not make any sense, but we're going to come down here and try to do that. Okay? So this is already done for us. That's not what I wanted to do. Yeah, don't worry about that. So we're going to take Okay, so we got to set up our numbers. So what we're going to do, and I know it's already done for you. You have to create this. This doesn't happen automatically. So our lowest number is 0. Okay? So that's where you start. So when you're making these are your intervals that you have to create. You got to make these. 0 goes here first because that's our lowest number. Well, then what's our class width? Add that on. Okay? So any number in between here goes in the first column. Now notice if you get a 5, it doesn't go there, it goes here. Okay, so you just got to be careful about that. Sometimes students will put like 4.99 there, and that tells them not to put a 5. So if that makes you feel better, you can do that. I find it easier just to go 0 to 5, 5 to 10. Notice we're just adding 5 each time. Just adding 5 all the way up. So we said that we were going to have 5 classes. So we started with 0, we added 5. Then the next class, boom, add 5. Next class, boom, add 5, add 5. So what was our biggest number? Is it less than 25? Yes. If our biggest number is bigger than 25, we messed up somewhere. You got to go back and do that. So before you start doing all the tallies, make sure your minimum number goes here and your maximum number goes here, and then you'll go through. So what you need to do then is to go up to your data set and just start tallying up these. You have to put them all in as a frequency. So you put these are your intervals. Here's your tallies. You have to go through. There's no shortcut here. So 10.2, I'm going to put a little dash down here. 10.2 goes here. Okay. And then if I scroll back up to 18.7. Okay, where's 18.7? 18.7 is right here. Put a little tick mark there. And so I know it may seem a little inconvenient. You're flipping back and forth from page to page. Then do 22.3 and 20. So 22.3, that goes here. Okay. 20, where does 20 go? 20 goes here. So if you're a number that's on the edge, you got to figure out where it goes. It should go in this category. And again, if it makes you feel better, you can do 0 to 4.99. And I would just do like 4.9 repeating so you can see that. But you can't put 5 wherever you feel like. You can't put 10 wherever you feel like, or 15 or 20. They have to go in the upper category here. Okay? If we didn't have decimals, it's not a big deal. You can do this category from 0 to 4, and this one from 5 to 9. But that's kind of up to you. There's different ways of doing it, but the tallies have to match. If your tallies are different than what they're supposed to be, then you messed up. And then frequency is just, well, how many tallies do I have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 1, 2, 3, 4, 1, 2, 3, 5, 1, 2, 3, 5. And that's the frequencies. So that's how you create your frequency table to then create your histogram. So constructing the histogram, basically all we do, we're going to take these intervals, these are the intervals with the X's, and you put them down here. So you went from 0 to 5, then 5 to 10, then 10 to 15, then 15 to 20, 20 to 25. Down here, you're going to put intervals of what you're talking about. I don't think does our background of our question have something to it? No, it doesn't have any. These are just numbers that are made up for this problem. So it doesn't have like ages or number of wins in a year for like baseball or something. So we're not going to be concerned with what exactly that label is, but if we were talking about ages or wins or how much money you made in a week or something, whatever it is, you have to put that down here. Okay. On the left side is your frequency. How many times did something happen? So that's how many frequency here, how many times things occurred. So this first bar goes up to 6, and then the second went to 5, next one went to 4, and the last two are at 5 and 5. So then you're just drawing your bars, and they have to touch. The last thing I would say, you need to write frequency. You can abbreviate. That's fine. You need a title. Don't forget your title. Gotta have it. Okay? Now we need to talk about relative frequency. So when we say relative frequency, is 5 a lot or is 5 a little? Well, 5's a lot if we're talking about a pizza and there's 8 slices. 5 is a lot. 5 is over half the pizza. If we're talking about 10,000 people, is 5 a lot? No. So we do relative frequency sometimes because we want to know, is it a lot or a little compared to everything else? So the only thing we have to do there, just keeping with the same data set, you're going to take these numbers, 6, 5, 4, 5, 5, and you're going to divide them by the total number. So F divided by N, frequency divided by the total number. So there were 25 total numbers. And in our first class, there were 6 frequencies, 6 things that happened, 6 tallies. So 6 divided by 25 is 0.24. And then you do 5 divided by 25, and 4 divided by 25, and then you do 5 and 5 again. And you get, these are your relative frequencies. They're percents if you want to think of it that way. 24% of the time, you're in this interval. Okay, 20% of the time you're in here, 16% you're in here, 20 you're in here, and 20 you're in here, because that's the decimals that went with that category. So if you're doing a relative frequency histogram, your interval is the same. You don't have to change anything for your interval. Your frequency, you still have to write down your frequencies, but now you have to add a column into that table. The relative frequencies, how do we get this number? We're going to take 6 and divide by 25. We're going to take our number in our frequency and divide by the total number of tallies. And so that's 0.24. And you get that for all 5 classes. And then you come down here. Now you might say, that looks like the same exact thing. You know what? Depending on your scale you use, if you look at that relative frequency histogram and the frequency histogram, they look exactly the same. Okay, and sometimes that will happen, and that's okay. There's nothing wrong with that. Notice, title. These labels are all the same. This is what's changed. So I need to write relative frequency. You can abbreviate too. And then I need to have my decimals. I need to have some units over here that help identify that. Okay? So that's how you construct a histogram. Now we need to talk about the shapes of our histograms. So one of the reasons we make histograms is so we can display data and we can make comparisons and analyze things. So some common shapes, the ones that we're going to deal with our class, you have symmetrical. So that means it's even on both sides and it's taller in the middle. Kind of looks like a bell curve a little bit. Okay? That's symmetrical. Does it have to be exactly perfect? No. If it's close, then you can call it symmetrical. And 2 people may look at the same thing and say, that looks symmetrical and that looks something else. And as long as you justify it, then you're okay. So there's symmetrical. The other one is uniform, rectangular. We really don't call it that. We call it uniform. It's when everybody's the same. You think about, what does a uniform mean? Well, if you're playing soccer or lacrosse, everybody wears the same uniform. You look the same. Have to look the same to play a sport in terms of your attire during a game. So uniform, everybody's at the same height. That can happen. Some other common shapes are skewed left and skewed right. Notice the tail is where the skew is. When I say the tail, that's where fewer people are. There's fewer people over here than there are over here. Okay? Skewed left and skewed right, again, you could, if you bump things around a little bit, it could look close to symmetrical. So you may have people disagreeing. But this is skewed left because the tail is skewing away. It's like falling off. Which way is it falling off? Not where more of them are. Where is it falling off? So this is skewed left. Where's the tail? Where's it falling off to? Think of it like a dragon or a dinosaur. Where's the tail going? Skewed to the right. Okay? Bimodal is when you have 2 peaks. Bicycle means 2. Bimodal, modal means mode, or the most occurring thing. So you could have skewed data that is also labeled as bimodal. You could have symmetrical that's also labeled as bimodal. But bimodal is when you have 2 things that are happening more often than the rest. You could have trimodal. We're not going to deal with that. But bimodal is 2 peaks. Okay. Any questions? Please ask.